This conference will now be recorded.
Hello and welcome to you all. In the today class, we are going to discuss about the concepts of classes and objects. So, in the previous class, we discussed some basic concepts about classes, how we can perform method overloading, constructor overloading, all that. Today, we are going to start with the topic that is there on your screen, recursion. So in the recursion is basically it's a process of calling a function again and again, and a function or a method is called a recursive method if the method calls itself. So the important point is, in case of recursion, the method should have called to itself. That is the important point. So over here on the screen, I have one very common problem, that is to find the factorial of a number. After this, we will discuss two more problems on recursion on Eclipse. So the first thing is in this problem that is there on the screen, we have one class named factorial. And in this class, we have one method. The method name is fact. This method return type is integer, and it receives one argument because we want to find the factorial of a number. So you have to pass a number whose factorial you want to find out to this function as a parameter. The thing that we discussed is that if a method is called a recursive method if it has a call to itself in its body. So if you look at this line, this over here, this fact method is calling itself. So this is basically the method call, and because this method call is in the method body, so that means this method is a recursive method. So there are two kinds of recursion. One is called tailed, other is called non-tailed recursion. We are not going into that much detail because that is not in our syllabus. So we will just discuss about what is recursion with this problem first. So first, if we start discussing from the main, in the main, the very first line is creating the object of the factorial class over here. So we are using a new that we discussed many times, that whenever you want to create the object, you have to use the new keyword and then the class name, and after the class name there should be a pair of parentheses. So this will call a constructor of factorial class, because constructor is not there in the factorial class. So Java will provide its default constructor. So that default constructor will be executed and a new object will be created. So that new object will have a reference f. So the next line, we are calling this fact function with 3. We will discuss just this line in more detail, because the rest of the lines in this main method are the same. The just difference is that we are calling this method fact with some different value. So let us discuss this f.fact step by step. So when you call fact, basically this is a local variable. So this 3 will be passed to the method parameter n. So I'm going to show over here the first call where n is equal to 3. So this is 3, right? After that, it will check that if n is equal to 1. So in case of a recursive function, there should be testing about the base criteria. A base criteria is criterion is the condition that becomes, when it becomes true, the function, the recursive function stops calling itself. So as we know, in case of n is equal to 1, the factorial will be 1. So n value n is equal to 1 becomes our base condition. So this base condition or base criterion is false because the value of n is 3. So this return statement will not be executed. So control will execute the next statement. So in the next statement, we have using variable r instead of this result, right? For to save time. So if r is equal to, this will evaluate to fact n minus 1. So this is the function call to itself. So here the function will call itself again. So when it will call itself again, this will call it with the n minus 1. That means it will call itself with the 2. So into the value of n, that is 3. So the function this fact will call here, the second copy of the fact will be called. So this is the first copy of the fact function, and when a function is called, uh, the current status of the function is saved on the stack. So its execution will stop temporarily and it will call itself again. So the second copy of the same function will start executing. So this 2 will be passed to this n again. In the second copy of this fact function, the another variable n will be created. So keep in mind this n is a local variable and it will be accessible within this first copy only, and this n is local to the second copy of the fact function, and this will be accessible within the body of the second function only. So because n is equal to 2, then next this condition will be evaluated. So n is not equal to 1 here, so this statement will again be executed. So here what we will get, result is equal to fact of n minus 1, because in this function the fact is equal to 2. So n fact minus n minus 1 will evaluate to 1. So into the value of n, that is 2. So this function will call itself again. So the third copy of the fact function will be created, and in the third copy the value of n will be 1. So this n is local to the third copy. So the next statement again in the body of the third function, if will be evaluated, this if statement, and this time the if statement will evaluate to true. So when it will evaluate to, this condition will evaluate to true, so it will return 1. So when it will return this 1, so there is a return statement. So when this will execute the returns 1, so this 1 will be transferred back to the function from where it was called. So this one will be returned back to the second copy. So that means the result of this fact 1 is 1. So now the multiplication will be performed. So 1 into 2 is 2. So that's the result. 2 will be assigned to the left hand side variable r, or result in this case. And when the next statement, return statement in the second copy will be executed, it will return the value of r result. So when it will return result, this will return 2 back to its calling function. So here 2 will be returned back. So in the first copy, now its execution will resume, and this fact 2 is basically 2. 2 into 3 is 6. So 6 will be assigned to the result variable of the first copy. So after that, the return execution of the return statement in the first copy of the fact function will return 6 back to the main, and here you will get 6. The result of this, you will get 6. So this factorial of 3 will give you 6 as a result. So this is how a recursive function executes. So I'm going to give you two more examples based on recursion. So in the first problem, we are going to find out GCD of two numbers using recursion. So if you can recall the process of finding the GCD of two numbers, so we discussed in the previous class that if you want to find out the GCD, what you have to do, you have to divide one number by the another, and when you want to divide the number, you will do one thing. You will find the uh, remainder, and after finding the remainder, what you will do is you will perform remind you about that. Remind you about that. Let me open the Eclipse first, then I will show you how that program can be implemented. So we'll discuss two more problems on recursion. The first problem that we are going to discuss is to find out GCD. If the important point over here is when we should use the recursion. So recursion we used for the problems, the problems those repeat themselves. For example, in case of finding the GCD, so what we will do, we'll divide 44 by 10. Let's say these are the two numbers, 44 by 10. We will perform this thing. So when you will perform this, you will get something, and that is you will get the remainder, right? So when in this case the remainder will be 4 if we assume that the two numbers are 44 and 10. So if the remainder is not 0, in that case we will perform the division again. But in the second step or the next iteration, what we do, if we make the divisor of the previous step as the dividend in the second or the next step. So for the next step, your dividend is 10, and the remainder will become the divisor. So remainder 4 is the divisor. So again, this will not give you 0 as the remainder. So you will get 2 as the remainder. So for the next iteration, the divisor of this iteration, that is 4, will become the dividend. Now 4 is the dividend, and the remainder, that is 2, will become the divisors, right? And we'll perform the division again. This time we'll get the 0. So this condition is our base condition. So when we will stop performing this division process, when the remainder will evaluate to 0. So this is the base criterion or base condition. So in case of recursion, first of all, if you want to implement any problem using recursion, you have to find out the base condition. Then only you can write the code for that. And the next problem is here. If I want to find out the sum of digits of this number, so how I can evaluate this? This problem is basically if you want to find out sum of digit of, let's say, 1 2 3 4, this will be equal to sum of digits of 1 2 3 plus sum of 4. Next is 4. So one sum of 1 2 3 is, sum of digits of 1 2 3 is 3 plus sum of digits of 12, sum of digits of 12, and sum of digits of 12 is 2 plus sum of digits of 1, right? And if the digit whose sum of digits you want to find out, if the number is a single digit, that means its sum of digits is the digit itself. So the sum of digits of 1 is 1 itself. So this is our base criterion or base condition. If the number whose sum of digits you want to find out is just a single digit number, then the sum of digits will be the number itself. Otherwise, the sum of digits will be the last digit plus sum of digits of the remaining digits, right? I think you got this problem right. So let's implement these two problems on Eclipse. So I have created one class over here and named it recursion1. So in this class we need a method. So I'm going to write the main method over here, public static void main, and there should be one string type argument. So within this we want to create some variables. One is whose n, other is d. So we need an object of the scanner class if you want to read the values from the keyboard. So this should be there, java.util.scanner. You have to import it if you want to perform the input or read the input from the keyboard. Now let's create the object of scanner class using this. So what this statement will do, this will basically create the object as we discussed earlier. Then you will create the object for the scanner class, and in this statement, when the object will be created, the constructor of the scanner class will be invoked, parameterized constructor, and system.in will be passed as a parameter to that parameterized constructor. So this is what will happen. So after that, we want to read two values, two numbers from the keyboard. One is this in dot next int, and the other one is in dot next int using these two statements. After that, we want to call a recursive function. So I'm going to implement a recursive function within the recursion1 class, because our main method is static, and as we discussed in the previous class, that this main will be able to access only the static members of the same class. So here, because recursion is the class in which we want to write both the methods, so this method should be the static one, static, and the return type of the GCD function should be int. So GCD is the name of the function, and we need to pass two parameters to this function or method. The parameters are, let's suppose, n and d. So you can use the same variables in GCD also, because these two are the local variables of GCD method, and this n and d are the local variables of main method. So in the GCD method, what we will test if n remainder d, if this is equal to 0, that means the base criterion has reached, and in that case our result will be the d. So when n remainder d becomes equal to 0, at that step the value of d will be the GCD. Otherwise, we'll call the same process, or we'll perform the division again and again, but here we are calling the GCD within the return statement itself. We will call GCD for the next step, and for the next step your d will become the n. So the first parameter is d. This d will be passed on to the variable n, and divisor should be n remainder d. So divisor is n remainder d. So here to this GCD function, you will pass the first parameter is basically the dividend, and the second one is the divisor. So when you will call GCD for the next iteration, this d will become the dividend, and a remainder will become the divisor. That's why I have written over here and a remainder d. So this is all about GCD. So what left is we need to call this function within the main. So I'm going to write over here system.out.println. So in the println method, we will call this GCD function with the n and d. So this will give you the result. So let's execute it and test it. I'm going to run it here. So when you will run it, you have to input two numbers. The first number is, let's say, 44. The second one is 10. So it's giving us the result 2. So let's test it with some different values. This time, let's say first number divisor is 10 and dividend is 44. Again, we are getting 2. You can verify this result using your notebook. And if I test it for one more input, the input is this, let's say, other one is 50, so 25 is the GCD. So I hope you get it right. So the next problem we want to implement is finding the sum of digits of a number using recursion. So again, I'm going to create a new class, and this class I'm renaming it recursion 2. The second problem on recursion. So in this case, we need a single variable n to sum of digits you want to find out, and we'll store the result in s. And because we want to read the input from the keyboard, so I'm going to copy the input line from the previous program and this scanner line as well, creating the object. For creating the object, these two lines here. So this line will create the object, and in next we'll read the value of n from the keyboard. Then we are going to call the function that we are going to write over here, but this time I want to create a separate class. So in the previous program we implemented a method in the same class, but in this example I am going to create a different class. So my class name is, let's say, number. This is the class name of the class. So in this class I need to write a method. So the method is basically it's returning integer. The method name is sum of digits, and we need to pass it a number, let's say n. And in this case, as we discussed with the example, if n is a single digit number, if n is less than 10 means it is a single digit number, we are assuming that the input that will give through the keyboard will always be positive, right? So I'm assuming that the input is positive. Otherwise, if the input is negative, if this value of n is negative, then 2 or 3 digit number can be less than the 10, because in that case n will be negative and definitely it will be less than 10. So the condition is we are assuming that n is positive. If n is less than 10, that means that is the sum of the digits. So n is sum of digits if n is less than 10. Otherwise we want to find the sum, and that sum will be n remainder 10. This will give you the last digit from the right hand side, or the unit place digit, and the remaining digits we want to find, call the sum function, sum of d again, with n by 10. If n is, let's say, this n value is 1234, then this will give you one, remainder 10 will give you 4, and this divided by 10 will give you 123. So this is what we want to do. So now the thing that is left is, if you want to call this function from this class, you have to create the object of the number class. So I'm going to create the object of number class over here. So number ob is the name of the object, and then you will write new number. So this will create the number object, and after that we need to call this SOD function, sum of digits function, that is recursive function, with OB object. So OB is the name of the object, dot method name is SOD, and to this SOD we need to pass the n value. So the value n is the parameter that we are passing. In S we will get the sum of digits, and I want to print the value of S through this printf statement. I'm going to copy it over here. So here I want to write S. So this will give me the sum of digits. Let's verify it. Uh, so here I'm going to input one number, this one, and we are getting the result 10 over here, because 1 plus 2 plus 3 plus 4 is 10. If I run it second time, and this time my input is this, let's say, I'm getting the result 26, because 6 plus 7 plus 58 plus 8 is 26. So one more change I want to discuss with you. If I make this function or method static, so you can make a method static by using this keyword over here. Although this we are going to discuss in the coming slides as well. So whenever you want to call the static method of a class, then you need not create the object of the class. In that case, you can call the function with the class name only. So here I can use this number.sod, and this is not required in that case because I have created a static method. So this is another way of writing this. If I make it static, SOD static, that means there will be no need to create the object of this number class to call this function. The static method can be called directly with the name of the class, as we have done over here. So this is the name of the class, and after that dot operator and then the name of the static method. So let's check it again. So if I run it, this will give you the perfect value, right? So this is all about recursion. Some more problems I will upload on the Google Classroom, and you can practice using recursion on those problems. So now let's discuss the next slide, the next concept. With this slide, we are going to discuss about the access control. So till now, we haven't used any access control in the class, but Java provides you 3 access specifiers, and these 3 access specifiers are public, private, and protected. So by default, if in a class you are not using any access specifier for the method or for the instance variable, then the method and the instance variables are public within the package. So within the package, this is important. I repeat, if you are not using any access specifier for the class members, then the class member will be public by default within the package, within the same package or within its own package. We'll discuss this term within its own package in more detail in the chapter package that we will discuss in the coming lectures. And the public and the private are rest of the 2 access specifiers. We'll discuss these 2 access specifiers with examples in the coming slides. So in this slide, we have one very simple example. So there is a class named test. In this class, there is a one instance variable a, and we haven't mentioned with it any access specifier. So its access is default access, and default access is public within the on package. So this can be accessed directly. So next is B, it's a public member. So we have written the keyword public before the data type. So that means this instance variable is public. So it has public access. So what's the meaning of public access? What is the meaning of private access? We are going to discuss very soon. And the next is C, it's of type private. So in this class, we have used all access specifier except the protected one. So this is the default access. A, B is the public access, and C is private. So this method set C is having default access because we haven't used anything before the void at return type, and get C is also of default access. So default access means that member of the class can be accessed directly using the instance name or object name. So here is what we are doing, that in this case we have created one test class object using the very first line. So this will create the object, this thing, and the object reference will be assigned to the OB identifier. Then we are using over here ob.a. This is called direct access. When you use the object name and then dot operator, then member name, then that is called direct access. Direct access means the member of the class can be accessed through the object using dot operator. So we are accessing that, assigning value 10 to the instance variable A. Then B is public by default, public, and this can also be directly accessed using the object name over here. But C is private, so private members of the class cannot be accessed directly. Directly means we can't assign value to C using this dot operator. So this is not valid because here this line we are using ob.c because C is private. It cannot be accessed directly, so we can't write like this. So this is the meaning of the private access. So private members of the class cannot be accessed directly means you can't use them using dot operator. You can't assign them some values. If the method is private, you can't call it directly with the object name. So this is the meaning of direct access. So this is not valid, right? So we have assigned 10 to A, 20 to B, and because this line is commented, and by default when the object is created, all the numeric instance variables are initialized to 0. This means the value of C will be 0 after that. So now we are calling this method. So ob.setC, we are passing 100 to this method. So the value of I will be 100 after this call, because in this case the actual parameters will be copied into the dummy arguments, this one, dummy parameters. So I is 100, this I we are assigning it to C, the value of C will change from 0 to 100. So in case of this object, the value of A is A is 10, value of B is 20, and that of C is 100. So the important point is that because C is private, we can't assign it value directly using this line that we written over here, but the C can be assigned value through some public methods. So this method C is having public access, default access. So this can be used, or methods can be used to assign the values to the private members. So that means the private members are now secure. These members can only be accessed through some methods of the class. So with the next line, we are printing the value of OB and C. So this OB.A will print A. Again, we are performing the direct access. We will get 10 over here. Then OB.B will give you 20, but OB.C cannot be printed directly. So you need to write some method. So there is a method over here, get C. So if you want to get the value of C, read the value of C, then you have to call this function getC. So ob.getC, when it will be called, it will return the value of C. So value of C is 100. So this will be passed back to this main, and you will get 100 over here. Right. So this is the first example on public and private access. We'll discuss more in the coming slides. So when should we use private? Generally, when you are implementing classes, and in that case, because data members of the class are the most important one, and you don't want that these should be accessed directly, so that the values of the members cannot be inadvertently changed, right? So for that reason, the variables of the class or the instance variables are made private to provide the security, so that these members cannot be unintentionally changed or intentionally changed. So here is the same class. The only difference is that we have used the private members. So in this class we are implementing stack, and stack implementation we discussed in the previous class as well. So the only change is we are making this array of type private, and TOS is also private. So that means these two members cannot be accessed directly through the object. So these are the two same public function, push and pop. So I'm not going into detail of these because this you know very well. So I'm leaving this for you. The only important point is because TOS is private, so you can't use it directly. This is the important line. And again, the array is also private, so array cannot be accessed directly like this. So this is the main point. If anybody has anything to ask about from this, you can leave your doubts in the chat box and I will answer those. So the next is the static keyword. So static keyword, I gave you one example already. So you can use a static with a class member. A class member means with a variable, instance variable, or with the methods also. So the methods can be static, or instance variable can be static, and how these static members will work, we will discuss about those methods. The important point is one example I have already given to you. If the method of the class is static, then that method can be called directly without creating the instance of the class, without creating the object of the class. And how you will call the static method? Using the class name. So this will discuss soon in more detail. And another important point is that we can't apply this super anyway. This we'll discuss in the coming slides. So in this slide, we have used static method. This main is a static method. Then there is a static block. So this is the block, and some static instance variables are there. These are the static instance variable, and this is static method. So in the use static class, there are three types of static members. One is static instance variable. So these are the static instance variable, this one. Then we have static method. This is the static method. There's a block. We are starting with the we are running the like this. So before that, if you write the keyword static, then that block is called a static block. So in case of a class, we discussed that variables or instance. Next thing that this class static block. So this is the static block. So the properties is that the static block gets executed when the class is loaded. I'm going to give you a brief description about this. We discussed in the very first class that when you compile the program, and after compiling, when you run it using Java compiler, then what happens? First of all, the class loader loads the class into the memory. The class loader module of the JVM loads the class or the bytecode into the memory. So this static block is basically gets executed when the class is loaded into the memory. This is the very first block that gets executed. So as soon as you will run this main method, you will run this program, the first thing that will happen is it will run this static block. So, and the second thing is when the class program is executed, the static variables are initialized automatically when the class gets loaded. So when you will run this program, this static variable a will get initialized to 3, static variable b will get initialized to 0, and then there is a static block, so the Java will run this. So after initializing a to 3 and b to 0, the Java will run this. So this static block will run before main. So keep in mind, whenever there will be the static block, that static block will run before main. So first thing that will happen when you will run the program, A will get initialized to 3, B will initialize to 0, then the Java will run this static block. So in this static block, you will get the first message, static block initialized. Then it will initialize the B to A into 4. The value of A is 3 into 4 is 12, so B will be initialized to 12. So after running the static block, the control will go to the main. So now the main will run. So when the main will run, it will call the math method. So this is the math method, because this main is static and static method can call another static method of the class. So that's why we have made it static. So this 42 will be transferred to X. So what will happen then? It will run the code of this math module or a method. X will be printed first, so you will get 42. Then it will print A. The value of A is 3, so you will get 3. Next, it will print B. The value of B is 12, so you will get 12. So this is what will happen. I repeat, so whenever there is a static variable, static block in the class, first of all, when you will run the program, static variables are initialized to their values. Default value is 0. If you haven't initialized it explicitly, then the static block gets executed, and after the static blocks execution is over, the control will be transferred to the main, and then the body of the main will execute. So this is the next problem. In this program, we haven't allowed the Java to run the main method. So this program will run without executing main. So basically we are stopping the execution of the program before the main executes. So as we discussed in the previous example, we have two static members over here. One is static block. So this is one block, and we have made it static using the static keyword before this block, just before this. Then there is a static main. So when you will run this program after compiling it, as we just discussed, first of all, the static block gets executed. So it will execute before the execution of the main starts. So when the Java will execute this static block, you will get this message, look at me, I am running without main method. And then after, the next statement will be executed, system.exit. This system.exit 0 will stop the program abruptly. This is the abnormal termination of the program. The program will end here. So control will not transfer to the main. So your program will end before the main starts due to this reason. So this will not get executed, and you will get just this result, look at me, I am running without main method, right? So this is all about this static block. Then we have another example to make the concepts more clear. So in this example, we have one class named student. In this student class, we have one attribute or instance variable roll number. One instance variable is name, and the third one is static string college. So we have initialized college to some value ITS over here, or we can use our own university, Chitkara University name in this case. So this is the class, and there is one constructor in it. So this is the constructor as we discussed earlier. Its name is same as that of class name. It don't have any return type, and it is parameterized because we are using two parameters over here. So then another method is there in the student class, that is display, and this is basically displaying the value of the name instance variable and the college value. So the next thing is main method. So when you will run this program, the execution will start from the main, and main is here. So its first execution, first statement will execute, and you will get this output student.college. So the first important point over here is we are using college before creating any object. So static members, instance variables, static variables of the class, these are not instance variables. So static members of the class, this is not called instance variable. Okay, why it's not called instance variable, we are going to discuss soon. So this is basically a class variable. Static variables of the class are called class variable. So this college is basically a class variable because its type is static. So class variable can be accessed without creating the object of the class. How you can access the class variable? For that you have to use first class name, then dot operator, and then the class variable name. The class variable name is college, and the college value is its, so you will get the result its. Then we are creating two objects. This one is the student object. So when you will create the object, what will happen? The constructor will get called. So this will be called 111 will be transferred to the variable r. The name current will be transferred to the variable n, and after that this roll number, instance variable, and name will be initialized to the value of r and n respectively. So this object is created. I have shown over here diagrammatically. This is the first object, and this object is being referred by the variable or identifier s1. So s1 is the name of the object. Similarly, we are creating the another object. So s2 is, this is the another object is being referred to by s2. So for this object, the references are basically stored in the stack memory in JVM. So s1 and s2 are there because these are the local variables, and local variables are allocated memory on the stack. And the objects are allocated memory on the heap. So this is shown over here. These two objects are basically residing on the heap memory, and their references are stored on the stack memory. So S1, S2 are on stack, but the memory they are referring to, the actual objects are on the heap. And both these instance variables are sharing the class area. So in the class area, we have one class variable college. So another important point in this case is the class variable is shared among all the objects. So there are two objects, S1 and S2, and these two objects will share this college variable. So for these two, S1 object, the college is its, and for S2, college is its. So in case of if you want to share some variables values among all the instances or among all the objects of a class, then you can create those variables as the class variable, because every student of a particular university will share the university name, so the university name should be the class variable. Now we are calling the display method. So display is not a static method. We are calling it with the object. So keep in mind, if it's a non-static method, then you have to call that with the object name. So another important point over here is these two methods this one main, this is main, and to call the student class display, we have to call it with the object name, because the display is the non-static member. So you have to write first the object name as well dot display. So this will be called. So in this we are printing the name, roll number. Roll number you will get first 101, name of the student Karan, and then the college, and college is your common area, so you will get ITS. So here we have another important point: a non-static member, a non-static method of the class can access static members of the class also, or the class variable also. So here college is static, still this void is able to access it, because the non-static method can access the static members of the class. But reverse is not true. Static members of the class cannot access the non-static members. So I think you get this example right. So similarly, as to.display will display the roll number, name, and college of the second student. So you will get the second result 222 RN, and the name ITS. Here is another example. In this example, we are finding the area of a triangle using the Heron's formula. So again, the two methods are in the same class, area class. Main is should be or must be static. So because within the main, we want to call the second method triangle area. So triangle should also be static, because main is static and it can only call the other static methods of the same class. So here we have initialized the three sides of the triangle. We have named the variables as L1, L2, L3. These are the three sides of the triangle, and we are calling the triangle area method from main. And because this is the static method, so it can be directly accessed, because this is also within the same class. So here this L1 will be passed to the first parameter L1. So okay, here also the actual parameters are L1, L2, L3, and dummy parameters are also L1, L2, L3. So these two names can be same, but their scope is different, so we can use this. So in the Heron's formula, first we find the sum of three sides by 2, so semi-parameter we find. Then the formula to find the area is, you will find S into S minus L1 first side into S minus L2 second side into S minus L3 third side. So whole square root we want to find. So what we did is we first multiplied these values and stored the result in the variable area double, and after that we are finding the square root of this area double. So how we can find the square root? We have one math class, and SQRT is the static method of this class, because we are calling the SQRT with the name of the class. So from that means this is static method, because it is being called with the class name. So this SQRT will find the square root of this area double and will assign the result to area, and then the next line will print the area of the triangle. So keep in mind, we are assuming that all the three sides forms a valid triangle, right? So this we are assuming. Otherwise, the condition for the valid triangle is the sum of any two sides must be greater than the third side. If this condition holds, then only those three sides will make a triangle, and subsequently you can find the area of that. If the sides are not forming the valid triangle, naturally the area cannot be found, or in that case you will get the negative result. So this program is written assuming that the sum of the three sides forms the valid triangle. Here's the another example on the static. So in this case we have some static members. First is A is static within the static demo class. B is also static, and call me is a static method. So this is one class. I'm going to draw a boundary of S, and the second class is this. So in this class, when you will run this, the main will start executing, and from the main we are calling the call me method, because call me method is a static method and you can call it with the class name. So that's why we have written over here the class name static demo dot call me. So it will call this method, and when it will call this, we are printing the value of a. A is a static variable, its value is 42, so you will get 42 over here. Then, because we haven't mentioned the access specifier of B, so that means its access is default, and in case of default access, the variable can be accessed directly within the same package. So we can directly access the B using the class name. So that is what we are doing in the next line. We have used static demo, the name of the class, dot v, the static variable name, and we are printing it directly. So this example shows you that you can either write a method to print the values of the static variables, or you can print those variables directly using the class name. And for that, you need not create the object. And the second condition is that the variable should have appropriate access specifier, then only it can be accessed. So again, we have the same stack class. I'm not going to into detail of this. The main things are that we have declared STK as a private, TOS as a private. The rest of the things are same. So I'm going to leave it for you. The next topic of classes and objects is nested and inner classes. So in Java, it's possible to write a class within another class. So you can define a class inside the another class. If you do this, then this is called a nesting of classes, defining a class inside another class. So the inner class, one is inner class, other is the outer. I'm going to show you here. So this is the class, let's say, and this class is, let's say, C. Inside it we can write another class, and this is, let's suppose, a class whose name is S. So S is the nested class, and this one we can call it outer class. So the S class that is nested inside C, this can be a static class or non-static. So how you can create the static class? You just have to put a keyword static before the keyword class. So whenever you will define it, you will put the keyword static before it, then that class will become static class. And if this class is not static, then it is called non-static inner class. So in case of the class is inner class is non-static, nested class is non-static, then the concept or the name this is used, inner class. Inner class means a class that is nested inside the another class, and it is non-static. And for static, the nested class is a static class. So this is the thing. So in simple words, we can say that this S can be either static or non-static. If it is non-static, then the concept is called inner classes. Another important point is in case of nested classes, this class S can access the members of the outer class. So S can access all the members of the C class directly. Directly means without creating the object of C class, all the members can be accessed. But C cannot access the members of S class directly. So whenever in C class you need to access the members of the S class, nested class, you have to create the object of the nested class S. Then only the members of S can be accessed. I repeat, the nested class S can access all the members of the class C directly without creating any object. But if you want to access S class within C, within the methods of C class, you have to create the object of S class. Then only the members of S can be accessed. So we are going to discuss what we have discussed in this slide in more details through some examples. So this is the first example. So in this case, we have one class named outer. I'm going to create a boundary of this class. So this is your outer class, and inside this I have created another class, and this is your nested class. So according to the definition that we discussed in the previous example, this class is S, that is nested, and this is C. But we have given it a different name. This outer class, this is the outer, and this one is the inner class. Because it is a not static class, the nested class is not static because we haven't specified static keyword here. So it will be called inner class. So according to that, we have named it inner. There are some methods and members in the outer class. So one is the instance variable outrx, other is a method test. So when you will run this, you have to, if you want to access the test method of this outer class, you have to create the object. So we are creating the object of the outer class over here, and then we are calling the test method with the outer object using this line outer.test. So when this test will be called here, we can within this, if you want to access the members of the inner class, that is if you want to call display, display cannot be called directly from outer class. This is what we discussed in the previous slide. So in the outer class, if you want to access the members of the inner class, you have to create its object. So to call display, you have to create object of this. So we are creating object of inner class in the outer class, and after that we are calling the inner.display. So we get into this after calling it. But within display, we can access the outer class directly. So we are accessing outer x directly inside the inner class. So outer.x will give you 100 over here. So I repeat the rules. From the inner class, you can access the members of the outer class directly. So we are accessing x, outer x directly over here without creating the object of the outer class. But the outer class cannot access the inner class. For that, you have to create object of the inner class that we are doing over here. I hope you get it right. If there is any doubt, You can leave your doubts in the comment section. Then there is another example. So in this example, we have one outer class. So this class is shown over here. Uh, Here, this one. I'm going to draw a boundary to make it more clear. So this is your outer class, and inside this outer, we have one class named inner class. Right? So this is a nesting of classes. One class is defined inside the another. So there is one member in the outer class, that is outer.x, and one method is there. And in the inner class, there is one member y, and two methods are there, display and show y. So if you want to use y in the outer class, you can't access it directly. So in this method, you can't write, in the test method, you can't write system.out.println y, because y is in the inner class and it cannot be accessed directly from the outer class. But this inner class member y cannot be accessed from outside, but outer x and outer underscore x can be directly accessed from the inner class. This we are doing over here, and we discussed this in the previous example as well. So in this program, we are creating the object over here with new outer. So this is small o, keep in mind, and the class name starts with capital O, right? So this is possible that you can give same name to the class and the variable, but case is different because Java is case sensitive, so Java will differentiate between these two. So with outer.test, we are calling the method of test of the outer class. So this will run. So within the this method, we are creating the object of inner class as we discussed in the previous example also. Then we are calling inner.display. So this will call this display method. So in the display method, we are printing the outer x value. We are directly accessing outer underscore x, and within this method, if you put another call, let's say this show y, then if you put a call over here show y, if you call it, then you have to write over here show y in this method, call it over here, and if you call it, then it will call this show y, and from show y we are accessing this value. So inner class method can access any variable of the inner class and outer class as well, but from the outer class, inner class variables cannot be accessed directly. If you want to access the members of the inner class, you have to create the object of the inner class. This is what we discussed in the previous example also. Here is another example on the same concept, but this time we have changed the program a little bit. We have defined the inner class within the for loop. So this is another important point. If you want to create the inner class, you can create even the class within the for loop also. So if you look at this is your for loop. Its body is starting from this place and its body is ending at this place, right? So this is basically is a test method, and in the test method we are defining another class, nested class. So this nested class is basically nested inside the for loop of the test method. So this is the test method, and in its for loop we have defined a class. So this is possible. So the logic, it will work like this. I'm going to explain the flow of this example. So from the main, we have created the object of the outer class, and with outer.test, we are calling the test method. So here is the test method. So in the test method, there is a loop, so it will initialize to 0, this index variable. 0 is less than 10. So in the body of the loop, there is a class, right? So if there is a class, then it's a definition of the class, but what will happen over here, uh, just the class definition is there, but this display function call is not there. So what will happen over here, this is the end of display, this is the end of class. So this will happen within the body of the for loop. This statement is also there. This is wrong, this is the end of the class, this brace, this is end of the for loop. Actually this test method, uh, this is end of class, this is the end of for loop. Right. I'm going to rub it, then I will show you again. So it will be clear. So this is basically the end of this for loop. This everything is there in the for loop, this part. Then it will be clear, more clear, right? This is the body of the for loop, and this display method ends here, and this class I'm going to label it 1, and this is the end of 1, right? So when this for loop will be executed, I is 0, less than 10 condition is true, so there is a class. This will just be skipped because it is its declaration. The control will come here, it will create the object of the inner class because this line is part of the for loop. So this will create object, that inner.display will call this display function, and you will get display outer x is 100, so you will get 100. With the next iteration, the value of I will change to 1, 1 less than 10 is true. Again, the body of the loop will be repeated. This is just the declaration of the class, it will be skipped. So again, second object will be created with inner dot new inner, and that will be assigned to the inner object, and inner dot display will call the display again, and you will get 100 again. So because this loop will run 10 times, so this will give you uh, outer x 10 times, or 100 output 100 10 times. After the completion of this for loop, the control will go back to the main, and there is nothing after that, so your program will come to an end. So the next concept is about command line arguments. So main, in case of main, you can look at this class slide, that there is one argument of the main that is of type string. You can pass some values to the main method when you are calling the main, when you are running the program. So when you pass the some values to the main method, then those values are called command line arguments. So when you run it, I have shown one statement over here. You have to write this line Java if you are executing it at command prompt, and after that, this is the name of your class file, that is command line, and these values that you write after the Java class name, when you run it, these values are passed as parameters, as arguments to the main. So when you run the program like this, then the values are passed to the main as an argument, and this concept is called command line arguments. So what happens in this case, the first value, that is this, is passed to this args array in its first index number, that is 0. So this will become args 0, and this will be assigned to args1, a will be assigned to args2, args3, args4, and -1 is args5. So basically whatever you will write after the class name, every word will be assigned to the elements of the array as I have shown in here. So after that we are using one for loop, I is 0, and this we discussed earlier also. If you want to know the length of the array, you can use the length attribute. Args is the array of strings, and this length will give its length. How many parameters are there? So 6 are there, I think so. So this length will return 6. So 0 is less than 6 is true. So what you will get is args1 or 0 is args0. In args0 we have this, so you will get this result. In the second iteration you will get is, because in args1 there will be word is. Similarly, you will get rest of the values on your monitor screen. So this is all about your command line arguments. If
This conference will now be recorded.
so, the variable length arguments, this is the next topic that we are going to discuss. So in case of method that we discussed till now, we used a fixed number of parameters method. So if you have defined a method in a class with 2 parameters, then that method can be called with exactly 2 values or 2 parameters. You can't call that method with 1 argument or more than 2 arguments, because at the time of defining the method, you mentioned within the parenthesis 2 variable with that type. But in Java, it is possible to create a method that can take variable number of arguments when you call it. So such type of method that can take variable length arguments are called variable argument method. So for variable argument method implementation, you have to follow this syntax. First, this you have to write the return type. It can be static or non-static. So I have written static over here, but variable length argument method can be non-static also. So then this is the return type of the method, and this one is the name of the method. And the important point is, whenever you will declare the variable argument, you will put 3 dots before the variable. So this v is a variable argument. It is type integer. So whenever you create the variable argument, Java basically creates an array of the type you have mentioned over here. So basically internally this v is an array of type integer. Variable length arguments method are also called variable-arity method as mentioned on this slide. So let's discuss the variable argument method or variable-arity method with an example. So in this example, we have one class named variable argument, and in this class there is a method named va_test. It's returning void and it's of type static. So in this method, what we are doing, we are first printing the number of arguments that have passed through this method, and then with the for each loop we are iterating through every element of array v and printing the element. So this will iterate through the loop. X will take one element from v at a time, and for that element the body of the loop will be repeated, and in the loop we have just one statement, so that will print x. That means that this loop will print all the elements of array b one by one, and then at the end this println will break the line. So this will print the output in one line. This method will print the output in one line. So another important point is this variable argument method can be called with 0 parameters also. In the first line we are calling va test with the single attribute, single parameter. So in this 10 will be passed on to v. So the value of the length of v will become 1 because we are passing just one value to it. After that, when this will execute, you will get the output number of argument v dot length will give you one contents, number of arguments one contents, then you will get contents word, and after that here you will get the contents of v. So b has one value 10, and that will be assigned to x, and this line will print x, and then the control will come out of this loop because v array has just one element, and this will break the line. After that, from the main, this va test will be called second time, and this time we are passing the three values. So that means this va array will be created of length 3, and 1 2 3 will be the values of v, and this time you will get number of arguments. V dot length is 3 because we have passed 3 values to it, and contents you will get one by one those, because x will take one value first from v and will print it, then x will take the second value, that is 2, and then it will print it, and in the last iteration x will take the third value 3 from the array b and will print it. So you will get 1 2 3 in one line, and then the line will break. And when you are calling it without any argument, then the length of v will be 0. So here is another important point: you can create an array with the length 0. This is possible when you create the array. A 0 length array can be created. This v dot length will give you 0, and because the v has nothing in it, so this loop will not perform any iteration, and the control will simply come out of it. So here is another example of example on the same, but this time this v variable argument is the second parameter. So keep in mind this point is also important. Whenever you create variable-arity method, the variable argument must be the last argument of the method. So here, because there are two arguments in this method, first argument is of string type, second is the variable argument type. But you can't reverse the sequence of these two arguments. You can't make the variable argument as the first parameter and non-variable argument as the second parameter. So this line is very important. So I repeat, whenever you create variable-arity method, the method should have variable argument parameter as the last parameter of the method. This point is very important. So this problem is based on this condition. So in this case, because one parameter is non variable argument parameter, so we can call this va test function with at least one parameter. So one parameter is required for the first, and for the second va argument you can pass n number of values, right? So I have shown you three examples over here. So from main we are calling it with the two values first. This one v argument will be copied into the first parameter msg. 10 will be assigned to v, that is an array. So this will be one element array because only one value it will get from the calling statement. And when the body of the method will be executed, you will get one vararg, this message, then v dot length you will get one contents. This loop will give you 10 only, and then with the completion of this VA test control will go back to the main, to the next line, to here. The second line we are calling it with four parameter. The three args, this will be copied into the MSG, the first argument. 1, 2, 3 will be passed on to the variable argument. So this time V is a variable argument with the length 3, and this we have already discussed. Not going to repeat it. And in the third case, we are passing just one value, so no arguments will copied into MSG, and there is no value for the second parameter, so this V will get nothing, so 0 length array, and then this body of the method will print MSG no vararg, length is 0, contents, this row will not be repeated, and you will get nothing. So in such cases, when the variable-arity method you have implemented, in that case the variable arguments must be the last parameter, and non variable argument methods should come before that. This is the last example on the classes and objects topic, and in this case we are implementing overloading VA arguments method. So in this case we have implemented how many methods are there. See, look at it. VA test, there is one method with the only variable argument. Then we have VA test with the Boolean type variable argument. Above we have integer type variable argument. Here we have Boolean type variable argument. And then we have one VA test with one non-variable argument, other variable argument. So as we discussed earlier, method, in case of method overloading, the methods can have same name. So all the three methods have same name, VA test. But there should be at least one difference in the arguments of the methods. So in case of first, the argument is of type integer, variable argument is of type integer, second is variable argument is of type boolean. So there is a difference. The difference can be of data type. So as in case of first and second method, the difference is of data type, because variable argument is in one case is of type integer, and variable argument in second method is of type boolean. And the difference can be of type number of arguments. So the third method, PA test, has two parameters. So it's different from the first two parameters because it has two parameters and the first two methods have just one parameter. I repeat, the difference of the return type is immaterial. So this all the methods are returning void, but if the method parameters are same but return type is different, then those method cannot be overloaded. So this is another important point. How this will execute, I'm not going to discuss the statement by statement, just I'm going to discuss with you which function will be called. So if you look at the first call, because all the arguments, all the parameters are of type integer, so a variable argument function with that can receive integer arguments will be called. So first copy of VA test can receive all integer type arguments. So this line will call the first VA test method, and 1, 2, 3 will be assigned to the array V, and the body of this method is clear to you. I'm not going to explain that. In the second case of calling, the first is a string and rest we have two integers. So in this case, the matching method is the third one, where it can receive the first string type argument, and rest of the integer type arguments can be assigned to variable array of type integer. So in second case, the third VA test will be called. So this line will call this method. And in the third method, because all the parameters are of type boolean, so these are the boolean values, true, false, true. So that means this will call this method. This is all about classes and objects. I think you all get it right. Happy learning.